Okay, so in this video we're looking at geometric sequences. You're going to be able to do two things with a geometric sequence. One, you're going to be able to find the common ratio, and two, you're going to be able to find the nth term. Now, you may not know what a geometric sequence is, but a specific example of a geometric sequence is a compound interest question. Compound interest is a geometric sequence. Now, a geometric sequence is just a pattern of numbers where each number is multiplied by a specific ratio. So a really simple example of that would be 3, 6, 12, 24, 48, 96. Now in this case you can see that from each term, one to the next, we are multiplying by 2. Times 2, times 2, times 2, times 2, so on and so forth. Now another geometric sequence might be something like 2, 6, 18, 54. Now in this case, each number is being multiplied by 3. Now you might be wondering about compound interest. Compound interest is the same. You start with a principal amount. Let's say you started with $2 in the bank, and in the first year, it increases by, this amounts to 300%. And then this one, the second year, 300%. And this one, the third year, 300%. So, really simple. First of all, if you want to find the common ratio in a geometric sequence, take one number and divide it by the previous number. So the common ratio here, that we'll call R, is equal to 54 over 18. Which is 3. We could have also said it was equal to 18 divided by 6. That's 3. We could have also said it was equal to 6 divided by 2. That's also 3. So in any case, to find the common ratio, take a number and divide it by the one prior to it, and you'll know what your common ratio is. Let's look at a formula now. We're going to start looking at this, finding the nth term. Now, the nth term, so term n, that's a subscript n, a small n. Term n is equal to a times r to the power of n minus 1. Okay, so quickly, you already know what r is. R is the common ratio. N is obviously the number of terms. The only bit that might be confusing is the A. That is the first term. Okay, so let's look at a question and see what we pop up with. So here's our question here. It says find the 20th term of the following GP. That stands for geometric progression, otherwise known as a geometric sequence. Now the geometric sequence is 10, 15, 22.5. Now remember, our formula for figuring out the nth term, in this case the 20th term, will be t subscript 20 equals a r to the power of n minus 1. Now the a is pretty simple, it's the first term, so that's 10. Now the r, remember to find the r, we take one number and we divide it by the other. So r is equal to 15 divided by 10, which is equal to 1.5. Now we can double check that by doing 22.5 divided by 15, because each one should have the same ratio between them. Now hopefully if you do 22.5 divided by 15, we'll also have 1.5. And you put that in your calculator and you will get 1.5. Okay, so we know our r is 1.5, and we know our n, we want to know the 20th term, so 20 minus 1. So 10 times 1.5 to the power of 20 minus 1, you can get your calculator out and figure that out straight away. Probably just before I go on, make sure you realize that it's not 10 times 1.5 to the power of 20 minus 1. It's 10 times 1.5 to the power of 20 minus 1. Slight difference there is going to give you a very different answer. Okay, so you can see 10 times 1.5 to the power of 20 minus 1. Here's our answer, 22,168.3782. 22168.3782. Okay, all of these funny decimals are happening because of the weird ratio. A lot of the ratio stuff you do, the ratio is going to be like 2 or 3 or 4, which results in large numbers once you get up to a pretty low term. But there's no reason a question couldn't be asked like this as well. Okay, so this is a geometric sequence. You've looked at finding the common ratio by dividing 1 by the previous, and then you've also looked at finding the nth term by using this formula, which is really important. Tn equals AR to the n minus 1. Okay, that's a brief intro to geometric sequences.